Welcome. This new module, we will learn about the FAIR uh, guiding principle, FAIR data guiding principle, and FAIR stands for, so in any project we do, we have data, yeah, we collect data, yeah, and sometimes it's a big data, and then what we do, we pre-process data, we analyze this data, then we post-process the data, we present this our findings and reach some conclusions, and we have outputs also. This output could be like the data, this output could be like the analysis, this output could be software, this output could be like a report or a poster or a manuscript or whatever, yeah. And in this fair data principle, like what we will learn is how to make all this data, like our input data, all these output, like follow the fair guiding principle. Fair means like you make your data like findable, oops, findable, accessible, interoperable. Interoperable means that your data has like a standard format that like people in your discipline would be common standard in your discipline, and people in your areas or in your domain would be able to deal with it, both like human and machines, yeah. And reusable, yeah, like how to make this data reusable. So basically that's what we will learn in this module. But in order to make your data fair and to follow the fair guiding principle, what you will also learn in this module is that you need to have a good data management plan. You need to have a good data management practices, because if you have a good data management practice, that's the gateway for fair guiding, like for following this fair guiding principle. So that would be like the second part of this module. The third part of this module is that we will do like an example. So I will show you like GitHub as an example for implementing or for following like the fair guiding principle. Okay, so let's get started. So so the first lesson in this module, we will learn about the fair guiding principle. Like, what is it? What does fair mean, and why it is important, and how to be fair? Yeah, how to follow this principle. So by the end of this video, you should be able to describe like the meaning and the importance of fair principles. Yeah. But also you should be able to identify ways like or tools, existing tools and infrastructure for making your data like findable, for making your data accessible, for making your data interoperable, and for making your data reusable. Okay, so that is basically like the learning objective of this lesson, and that's what you should be able to do by the end of this video. Okay, so let me ask you these tricky questions that I like to ask you. This is not really a tricky question, but just something to get you to think. Yeah. Uh, so when is a research project completed? So yeah, pause the video and think about it. Like when I could say, okay, this research project is completed. Okay. Okay, so we can say what is a research project? Like what you are doing now, yeah? So what you are doing now, you are not actually doing the research, you are planning for it. So you are writing a proposal, you are in the planning phase, yeah? In the understanding and planning phase. Then you will prepare a proposal, then in the project course or in the thesis or whatever, you will implement this, yeah? Uh, And then after you implement this, you can present your results at EagleX, like a poster, for example. Like you will publish it, yeah. After you prepare, you're done with your research, you publish it. So you can publish it as a poster in EagleX, or as a report, or as a manuscript, or whatever you will do, yeah. Uh, so that is the traditional way of doing research. Like you conduct your research and then you publish it as like a report, as a poster in EagleX, as a manuscript or a paper in a peer review publication or whatever. Now there is a new paradigm that is emerging, and this new paradigm, and in this old paradigm, what do we do? Or what is the, like, before I tell you about the new paradigm, what's the drawback of this paradigm? So the drawback of this paradigm is that, like, you, like, let's say your final product is like a paper. You publish the paper. Then you publish a paper, and at the end of this paper, like, if you, all these papers that you're reviewing, you'll find at the end of, like, some of them, especially old one, you will read something like this, like data availability statement, and under the data availability statement, you will say data and codes used to produce this paper are available upon contact of the corresponding author. That's it. And where will all, like, when you did your research, you collected a lot of data, you did a lot of coding, you might have developed the software, you might have collected a physical sample. Where did all this go? It's just, it's hidden. Like, all what remains of it is just like this paper. Yeah. Now there is a new paradigm which is emerging, which still, like, you will conduct your research, yeah, and then you will publish your paper. So that's like this step here. But now you have all these things in between. So what are all these things in between? You need to manage the data on a data repository. So you need to manage your data. You need to annotate your data, like put a lot of meta data, like, and lot of detail to be able to describe your data so that other people will be able to understand it and use it. You should not only annotate the data, like, but you should annotate the analysis steps and the code. So if you have any code or analysis step, you also annotate this. Then you publish your data set. You publish your codes or your messes or your analysis step. You link the paper and the data sets and the codes. So now here, instead of having like this statement, here you will have all these products that go hidden. So that could be, for example, your data. That could be like a software that you developed. That could be a code. That could be like a physical sample, yeah? Like an actual physical sample. And I will show you like what to do with this physical sample, like how to provide metadata for them and cite them in your work. So all these things, like you make these data like available, yeah, and then instead of having this statement, you link it to the paper and then you publish your paper. So now you have to do all this additional work, but is it worth it? Like, or why do I need to do all this additional work, or why this additional work is useful? So that's what we will learn. That's part of what we will learn about in this lesson. We will learn why this additional work is useful, and what are the available tools that will help me to make this possible. Yeah. So let's start with just having an overview on this fair data guiding principle. So let's say, for example, like uh, one of your co-workers or like a friend, like on a dinner party or whatever, asked you like, what did you do at FGCU? Like, if you're doing a master, like, what did you do there? Can you tell me anything interesting there? Then you tell him, yes, I spent, like, for example, like 1 year working on this like a research project, and you tell him about like this research project that you spent 1 year doing, and then he will tell you, oh, that's cool. I would like to read more about this. Can you send me like some of your output, like a report or a poster or whatever you did? Then you tell him, okay, I will email you. Then you go, you open your file, you search for your file, and you try to find what report you did, and is this the last version or not the last version, and so on and so forth. Yeah, that's because your data is not findable. Yeah, but if you are following the fair guiding principle, then you will tell your coworker, or like in your job interview, like let's say this could be a job interview, you will just tell them, oh yeah, I will give you the DOI. You just give him a link, or even URL. Yeah, that's so you just like give him a link. That's, for example, like your course. It just follows this principle. Like, if somebody tell me, what are you teaching in this course? What do? I tell them, oh, I will go to Canvas, download the syllabus from there and give it to you. The syllabus is on Canvas, yeah, and it's in the PDF. But in addition to having like a syllabus on Canvas as a PDF, I have a link. So I just give him a link. So I'll tell him, yes, if you want to know like what I'm doing in this course, or like what one student want to take this course and what I'm doing, then I will tell him, okay, here. This is the link. I will just give him a link. He will go there. He will learn about like this project. He will learn about what we are doing, the project requirements, the lessons. He will see also these lessons record, and he will get like all the information. Just a link. So that's because I made my data findable. Then make my data accessible. I could give him this link, but he goes there and he finds it that he cannot access it, yeah, or that this server is down, or he has no access privilege to it. So make sure that you host your data in a trustworthy repository, trustworthy server or repository that will hang around there for a good amount of time. At least like for this course, for example, at least it will hang around through this semester, yeah. So that's like GitHub. So the repository here, I make this data accessible through GitHub, for example. And then make your data interoperable. Like make your data like once your friend was able to find your data, yeah, and access your data, and then he wants to see some of this data that you use, and then he wants to use this data or see look at the data, but he found that maybe you are saving this data in a binary format, and he doesn't know how to open this binary format. Yeah. So interoperable means that you make your data available in a standard that's common to your audience, to your expected audience. So, and we will talk about this. You need to know what are your expected audience and what your expected audience can read and they cannot read. Yeah. So if your expected audience are engineers, for example, then your data could be available in an AutoCAD format because you expect them to be able to open a file like this, an AutoCAD file. But if they are not engineer, that will not be the appropriate like extension, or format to share your data. You might think of other methods, yeah. And then reusable. Let's say like your friend found this data, and your friend found this data, and he find it very useful, and now he wants to use it, but he doesn't know how to use it because he didn't provide the license. You didn't say like, is he allowed to use it, under what condition he's allowed to use it, under what condition he's not allowed to use it. He will call you and he will tell you, oh, can I use this data? And then you can explain this to him. But if you are sharing this data with a license, then he will know. He wouldn't need to call you. He will just like use it. Yeah. Okay, so that is basically like the fair data principle in a nutshell, or like in an easy term to explain. Yeah, but without further ado, let's just get started. Yeah, let's get started and we will learn more about it. Yeah. So to make your data findable, as I told you, there is already an existing tools and infrastructure. So to make your data findable, you usually use like something called like persistent identifier, like object identifier, DOI. That's an object identifier, or researcher ID, or a project ID, and we will learn about this. To make your data accessible, you need to use like you need to put it in a repository out there, like and then that need to be a trustworthy repository, and we will learn about like what are different repository out there and for what purpose. For the purpose of this class, and if you are taking your project class, if you are taking the project class, the repository that you will use for sharing your data, that would be GitHub, like this one. And I will provide you with a tutorial in this module on how to use GitHub for sharing your data and for providing license for your data also. Yeah, to make it reusable. And then interoperable, you need to use like standard format and common language in your discipline. So that would be discipline specific, yeah. And then reusable, you need to provide a license for your data. And for example, Creative Commons, and we will learn about like what the different licenses that are available. But you can even go beyond just providing license. You can improve like you can make like you can improve the accessibility of your data with other tools, yeah. Okay, so fair data in a nutshell, like so we learned it, we got an overview on fair data. Like let's now get started. And before we get started, I always like to start with why, like why this is important, or why we are doing this. uh, so the reason we are doing this because like we want to do some extra work. Yeah, we have plenty of free time and then we want to do some extra work. No, that's not why we are doing this. The reason we are doing this because so fair this is like a cutting edge topic in research. So that's called like open science, yeah, and it is an important development in research worldwide. Remember the last module we were like or one of the previous module, not necessarily the last one, we were talking about like ethics in research, yeah, and how people will fabricate or falsify their data. Well, when you are fair, when you are sharing your data and you are sharing your step, that will eliminate this, yeah, or to a large degree, not eliminate it, but to a large degree. Still, like if you want to cheat, you can still cheat anyway, one way or another, yeah. So that will eliminate, like, reduce this significantly and will increase, improve your reputation as a researcher because everything you're doing is open, yeah. Everything you're doing is transparent. Everything you're doing, like you're putting all your data, you're putting all your code. If somebody want to reproduce your finding, he or she can reproduce your finding. But that's not it. Like in the next slide, like that's the coming slide, I will show you why this fair data is very important, starting from you as a researcher to the wide community. Yeah. So I will show you like how this fair is important. To be like another important thing is that like to be fair, like to follow this fair guiding principle and to be able to share your data, you need to have a good data management. So let's say you didn't have a good data management and then at the end of your project you want to be fair. That will take you some time to organize your data and get it in shape and put everything in order. So you will but if you have a good data management from the beginning, at the end, or as you being also fair, like throughout the research process, at the end of the project, you would be done. You wouldn't need to do anything extra because you already have a good data management. Uh, Now, one of the misconception about FAIR is that people think that I should be sharing everything. Yeah, that's a misconception. You should not be sharing everything. So all data must be managed. So any data, you must manage it. That's for sure. Yeah, but all data, but not all data need to be open. So that's important. So for example, like you work in a company and this company have like a certain method, and this method, that what makes this country unique over other countries, that what give you an edge over other companies. For example, you should not share this type of data, you should not share this type of method. Or like you are a graduate student or you're a postdoc or you are a researcher and you collected some data and you need this data to publish it and you don't want to share it, for example, and somebody will misuse it or like use a method and publish it before like you do, or you get into trouble. So you should not share this, yeah. So basically you should use your best judgment and see like do what I can share and what is is uh, is what I cannot share, what's not on the interest of my research group, of my interest, and the wider interest that I should not share. So the rule of thumb is be as open as possible. So be as open as possible, but as close as necessarily. Yeah, so that's very important. Be as close as necessary and as open as possible. So you need to use your best judgment here. Okay. Uh, Now, that's also another thing. Like, FAIR is not a compliance check because FAIR is now like this is now a requirement by funding agency like NSF, NIH, other funding agencies. That's a requirement for them. It's not like it's not an extra thing that you will do to make your proposal look attractive. It's actually a requirement. You need to submit a data management plan, yeah, and you need to share your data, not just submit a data management plan, but actually do it, yeah. Because this is research is funded by public money, yeah, and this your findings, not just like a paper, like the whole process need to be, again, when I say the whole process need to be available, also as open as possible and as close as necessarily, yeah, that's what I mean, yeah. But we will see, like I will show you in the next slide that this is like a change in culture, and this will very will have a high return on you as a researcher and on your research group and on the community, like as like the scientific community and your stakeholder as in general. Yeah. The last principle, like, or last guiding principle I want to share with you is stakeholder should be actively participating in defining not only what data to share, but even your data management itself. And that's what I was telling. Like, you should see who is the audience of this data, who will use this data, and based on knowing who will the audience of this data and who will use this data, you should involve them from the beginning by letting them define what data they expect from you, what output they expect from you, and in what format they expect this output. And so that is also another important thing, is that like from the beginning you involve your stakeholder in the data sharing and even before that, like the data management. So this is basically like the fair guiding principle in a nutshell. What we will be doing next is that I will show you why fair is important for you. Like, why fair for my average research? Like, I mean, like, I'm a guy uh, who is doing this research project here for like a year or like this semester or like doing a thesis or whatever. Like, why do I need to be fair, or why do I need to be fair for my average project? But why fair? Like, if you become like like if you become like research, like become like an important part of your career. So generally speaking, so I will just show you why this is important for you as a researcher, for your research lab, for your colleagues, for the scientific community in general, and for the product community. I will show you this one by one. But generally speaking, why do you need to be fair for your average research? Because it satisfies the editorial and funding agency requirements. That's the general thing. So if you have to do it, that's like by as you bind it by your funding agency, but you also have to do it for now, most reputable publication now, they require that you share your data. Or they require, and if you are not sharing your data, you need to provide a strong justification why you're not doing this. Yeah. So it's this is generally speaking, but other than like this checklist, so that you can say, okay, so this is just a checklist. No, it's not just a checklist. For you as a researcher, fair is very important because if you are not fair, you might regret later not being fair. And I can tell you that most of us has passed through this experience. Like, we did something, and then we have like some data, we wrote something about it, and then we left it, and maybe after some time we went back to it because, oh, you know what, I need to use this again for another project or for a similar project, for a similar task. Then you go back to what you did before, and then you look at it, and then you don't understand. Okay, what is this data? What does it mean? Why this heading is missing? What does, like, for example, you find some weird symbol ML? What is ML? And uh, and then you say, okay, why? And then you will regret it. Like, when I was doing this, why I didn't provide sufficient details so that when I get back to it, I will understand what I have done. Yeah. And I'm sure like many of us has passed through like this experience before. uh, because let me tell you this, and this is important for when you work on your project or when you work on your thesis or whatever. The time you remember something and you understand it most and you have a vivid understanding of it is when you are actually doing it. That is when you remember this, and that is when you need to write this down and need to document like uh, all this information so that when you go back to it, you will remember. Let me show you an example. Like, okay, let me just show you an example. Yeah. So here, this is something that I just did like recently. Yeah. So let's say like Peace River. Yeah. I was collecting data about like these Peace River. See, everything I learned when I was collecting this data, I just added it here. I put the links here, and then here is the code that will help me to find like this is the code that will like go and like retrieve this data and process it, for example. Yeah. And then here I'm plotting my results. When I plotted my results, there were several like monitoring stations. So I learned about this monitoring station and I put like this detail here. So you see everything I'm learning, see like Peace River Nutanix, this is what I learned about, this is what I learned about. See, I put it down. So now if I want to go back again and let's say do this for another watershed, I have all the details. See, that will save me a lot of time and a lot of effort because I now would remember, okay, I need to go to like this like URLs. That's where I will find the data. When I go to this URL, like I need to go here, here, here. I will need to do get this into like cubic feet per second. That's what the data will be. So you see all the detail. Same here. The quality control of the data. I learned what does this quality control simple mean, and then I put them down here so that I don't need to do this again, and so on and so forth. So you see everything I am documenting it, and that when then I wouldn't regret being fair. Yeah. So annotating your data and how you access your data and how you find your data and how you process your data, that will help you uh, not to regret to be fair. Yeah. Uh, I mentioned also like as a researcher, it will improve your reputation. Like you could like lose trust if your data is not fair. Uh, uh, you could lose trust if you're not fair because sometimes like when you see somebody hiding their data, you might see, okay, is there something fishy? Like what are they hiding? Like why, what they don't want us to see? Yeah. So you could be lose trust if not being fair. Yeah. So because like remember I told you like if you are not doing reproducible science, you're not doing science at all. That's another rule of thumb. If you are not doing reproducible science or reproducible research, you are not doing research or science at all. Yeah. And then another thing for you as a researcher is that like you make the data like a first class research output, not just like your final paper or like poster, but the data itself. It become like just as a paper or as a poster or report, it become like a first class research output. You could get credit for this. And some journals, for example, like Elsevier, you could publish your data. So they have like, in addition to publishing your papers, they have something called data and brief where you could publish your data, so you get credit for this. You could even publish your method, like your steps. You can publish your steps, like this is called method X article. So Elsevier Journal provides this service where you can get credit for your data. Make your data count. This site will is developing data metric for data research and impact. So that's like if you are a researcher and you are applying for promotion, for example, or whatever, you can go to you can just also get credit for the data and not just your paper. Yeah. But for your research lab, same as here, not regret being fair. Like let's say my research lab, uh, I have like a graduate student like who wants to pick up this project. Yeah. Or an undergraduate student who wants to pick up this project. Yeah. So what do you do? Like you just give him a link and tell him go there. You don't need to be there with him and explain to him everything. He just can go there and he will find like all the details he need to reproduce this. And let's say uh, like actually one student did this. Like I did this for like Peace River, and then I wanted to do it for Caloosahatchee River. So I told one student do this for Caloosahatchee River. What did I do? I just give him a link. He went there. He was able to redo what I did here, but for another watershed, which is the Caloosahatchee River. If I was not fair, imagine how much time I would need to spend with him to show him like how to go to like these web like dashboard and gets the data from there and downloads the data from there. Imagine like how much time it would have taken me and would have taken him to like redo something that's already has been done. Yeah. So that's for your research lab, but also the other way around. Like you get like a graduate student or an undergraduate student or a postdoc, and you invest a lot of time in training him and he invests a lot of time in doing the work, and then he finishes work and he left for another job. And what he will do, he will tell you, okay, I will give you what I have done on a memory stick or like a file that you will put somewhere in your computer and you will forget where they are. Yeah, and if somebody told you want to see this, you will keep digging into your computer to find it. But if your student is following like a fair guiding principle, the data will be available, and then you can easily share it. So, so that would be like useful. Like then you don't need to reinvent the wheel. Uh, uh, like all these investments in your student and postdoc, it will be recorded, and other student can pick it up and continue on it. Yeah. And more importantly, if for your student to be fair, they need to have a good data management practice. You'll ensure that they also have a good data management practice. For your colleague, that has different like for my colleague, for example, like when I share my data, like let's say I have like a colleague, we want to work in a new project together, or we want to discuss something together, then we go to what I've done before, and we can share this, like I share this with them, and we look at the details, and we can look at all these details together, and that improve collaboration and make things more efficient. And I've done this before, and I can tell you that makes really things more efficient. Yeah. So share and discuss data and codes with colleague for current and future project, and that makes really things more efficient. Yeah. Uh, uh, well uh, managed and well annotated data that improve engagement. Yeah. That I told you, like if your meeting will make your meeting go from instead of 2 hours to only half an hour, because everything is there, everything is clear, and you can just like discuss like all the aspects, or like different aspects of the research that you are doing in, and you can easily access things. Yeah. So that is for your colleague. For the scientific community, it will enable like this data to be used by human and machine, and that will improve uh, it will improve actually your citation, because people will not only find the report or a paper, but they will find the paper, and if they want to redo what you did, they will find the code, they will find the data, so they have like a solved example that they can use and solve. Yeah. And if they use your code, they will say, okay, like we use this code, and they will cite your paper, and they will cite what they did, so it can improve like the citation, because you are improving the broad access of your data product. Yeah. And you make like science more open, like this called open science, and more transparent and more useful. But for the broad community, and that's what I said there, if you are carefully planning how to share your data with the broad community, with the one who's going to use this data from the beginning, that will make your research more impactful for the community. Because remember, we are doing science uh, not just for the sake of discovering new things, but uh, ultimately, I mean, that's basic research, yeah. But ultimately, the objective of this is to do something useful for the community, yeah. And if you are doing like applied research or an R&D research, it's good idea like you to involve, like to make your finding accessible to your audience, to the stakeholder who will use from this data. Let me show you an example. Like, so here, this is like a project that we are working on. Yeah. So we make like we put information about the project. We put here some of like our data that we will able to process, more data here that we will able to process. But then here this we sharing also the reports, the outputs of this project, so that people like our stakeholder will be able to see like our current progress and our current outputs. But let me show you something, like some of our stakeholder, this data might not be like, let's say for example, like this is salinity data. Yeah. This for whole South Florida, it might not be useful for them, because let's say I'm a farmer, let's say here at this point. Yeah. And then I want to know, for the next 10 years, like this well that I'm drawing water from, how will salinity increase like with climate change and with like sea level rise, for example, in the next 10 or 20 years. This data is useless for them. I mean, what does he learn from this figure? Nothing. Yeah. So that's what we are trying to do. We're trying to make our data more accessible by building like an interactive dashboard where, like, through like natural language, the uh, our users or like the stakeholder will be able to get the data as they need. So I'm a farmer. I will just go through natural language and I will say, okay, I am at Immokalee, for example, in this location at Immokalee, and I want to know the salinity at this location for the next 10 years. And he writes this like with natural language, yeah? And then we will build like an AI dashboard. The AI will take this, will go through our data, retrieve this data, plot the time series for him, and give him the information he needs and explain it to him. So we are making our data even more accessible, yeah? So that's we are taking this like to a next level, and that is how we can make our data, like, this is the accessibility, like make it easy accessible for the broader community, because like a farmer will probably not be able to use like Python or GIS to go to our data and extract like the information that he would need from it, yeah. So that is how it could be. Like, so I hope by now you would appreciate like why fair for my average research, yeah. So now let's go to this fair guiding principle. So we learned now the why. Now let's learn of the what. Like, what is fair? Like, what is findable? What is accessible? What is interoperable? And what is reusable? So, so now let's learn about like the what part. Like the what part. Okay. So to make your data findable, as I mentioned, you need to provide like an object identifier, like a persistent identifier, like a DOI. That's a persistent identifier. URL is not a persistent identifier. I will talk about it, but so you need to provide like a persistent identifier, and we'll talk about this. But you also need to annotate your data, because when you annotate your data, and provide a lot of metadata, that will make your data searchable by search engine. Like, imagine like your data does not has any annotation, does not has any keyword, it will not be picked up by search engine. Yeah. So you need to annotate your data. Accessible, you need to find like a repository where you can host your data and make your data accessible, like at least allow the user to download the data. Some repository will allow the user to even open the data, like if it's a PDF file or if it's like a Jupyter notebook or whatever, like GitHub, like if you have a Jupyter notebook for Python, like sharing a Python code like this Jupyter notebook. So a Jupyter notebook, that's a Jupyter notebook. This is what I just showed you. So that's like an example of a Jupyter notebook. Like a Jupyter notebook, it allow you, it has a markdown cell where you can do the annotation, and then it has a code cell where you put the code, and then when you run your code, you will get like your output here. That's called like a Jupyter notebook, yeah. And now in this, what we did here, we collected, like we have several Jupyter notebook, we collected them into something called like a Jupyter book. So that's the Jupyter book. It's a collection of notebooks, yeah. And so you can make like your data accessible by putting it like in a repository. Like in this example, for example, like we make the data accessible by putting it on GitHub. You can see here like we put it on GitHub. Yeah. And it should allow for the download and the manipulation of your data. So like, for example, like this GitHub, see, if I want to download the Jupyter notebook, I just can click here and then it can download it for you. Yeah, it will download the Jupyter notebook. Or and accessible, like here you can not only download it but you can also view it. So you see here you are not just downloading but you can also view it. Interoperable means that you use a format that's standard in your industry, and each industry will have this standard format. Like a binary data, for example, that might not be the standard format for your industry, yeah? And you should use, like, when you document and you uh, structure your data, you use common vocabulary in your field and common standards and vocabularies in your field. But again, these details are beyond the scope of this course. So to make your data findable, you need a lot of metadata. To make your data accessible and interoperable, you need community infrastructure, and that is there, like GitHub, for example, like this community standards and vocabulary. I will show you some examples now. Yeah. And reusable, you need to have policy and documentation. You need to provide like license for your data. Yeah. So you need to provide the license for your data so that the user will know how to use this data. But also you need to have a lot of annotation and a lot of metadata so that if I want to reuse this data, I need to understand what this data is. Yeah. And what does this data mean? Yeah. So what does this data is at least, and what does it mean? That will make it also more reusable. Okay, so let's just look at some of like what does it mean to be findable. So I'm not going to read this, like you can read it if you like, but to make it findable, the most important thing is that like you provided a persistent identifier, like a persistent identifier that is like a digital object identifier. So what is the difference between a URL and a digital object identifier? So a URL, this is like an address. A digital object identifier, like a DOI, this is more like your identity. So for example, like a DOI is this, like you can think about this like your social security number. Yeah. While like a URL, that's an address. So like here, what I did here, this is just a URL. This is an address. Like so this address could, like this link could be broken or it could be changes. But a DOI, this is not like a link that could be broken. A DOI, it has a link also, but it's not just a link. Like a DOI, this is a long-lasting reference of a digital resource. So basically, this is a documentation of your digital resource. And even if where you are hosting this data, like the server where you are hosting this data is down, and even if you are, the internet is down, yeah, uh, this digital resource will still be identified, like with its like at least like the title, the abstract, the author name, and so on and so forth. This and that's called like an object identifier. Yeah. So an object identifier, yes, it has a URL, it has like it has like a DOI, it has like a link uh, where you can also like access the information, but more importantly, this is like you can think of it as the identity of the data. Yeah. So even if the internet is down, this information will remain there with the DOI. So this DOI is like refer to your basic identity or basic information, like your age, for example, like your uh, whatever. Yeah. Your name, your date of birth, yeah, like things like that, yeah, that will be like DOI, like your identity or how to get a DOI? You can do this with Zonado. In this course, or even in the project course, I don't expect you to do this, but I just want you to be aware of this. Like in this course, if you just provided a URL, that should be good enough. But to get this, you can do this with Zonado. And maybe when I get to like when I show you like how to use this GitHub, I can maybe a little bit talk about like Zenodo, not Zonado, Zenodo. Okay, that's how you can get a DOI. Uniform resource identifier. There is also so a uniform resource identifier, like that's like a DOI. Like DOI will have like a URL, that's like a DOI without a URL. But now let's say if your data, yeah, is not like a digital data, it's like a sample. Like you went to the field, you collected an actual core, an actual sample. Well, there is also something called international generic sample number. So you can get like this is also a persistent identifier. That's the international generic sample number, and you see here, and that will be like a persistent identifier that will include like persistent information about like your samples that you collected. So that's called also this one. Yeah. Another example of persistent identifier is researcher ID, like this researcher ID, ORCID. Again, that is a persistent identifier. Like each researcher will have a unique identifier. Let me show you mine, for example. So, like if you go here, you go here. See, that's ORCD. That's a unique identifier for each researcher. And this unique number, again, that is unique regardless of the URL, regardless of like if the internet is down, this unique ID will be there and it will connect like my research works that I have done. So you see like this, it will connect my research information. So that's like my ID, my research ID number. You can do the same for like a research activity, like your research lab or a research project. You can get it like a research ID that will also be a persistent identifier. A resource, like a research resource, like a software or a code you develop or whatever research resource, you can also get it RRID number and so on and so forth. Yeah. So these are persistent identifier, and the persistent identifier, this is the identity of this resource rather than a URL on a server that could break. So again, if the internet is down, the internet disappeared. This information should be there and available because this is not URL. This is like your social security number. Your social security number is, if the internet is down, I mean, there's no URL that will take you to your social security number, of course. I mean, this because there's a private information that's not available, but that is like a persistent identifier. That's how you make your data findable. You also make your data findable, as I mentioned, by putting a lot of metadata. So to make it findable by search engine. How to make your data accessible? To make your data accessible, you need to have a trustworthy, accessible repository. So there are different types of repository, like which repository will I choose for hosting my data. So there could be like the funder. Of course, the first thing would be the funder and institution repository. So if your funding agency tell you you need to share your data on this specific repository, then the question is answered. Yeah, then you share it on this specific repository. If your institution, like your company, is telling you you need to share your data on this specific repository, like a company repository, then you need to share your data there. And usually, engineering company, they have a very good data management system, and they have their own internal repository where you share your data about project, like uh, designs, for example. So I work at an engineering company. We were designing power plants, and they have a very strong like data management system where you save all your design, and that would be internal repositories. They will not share this information with uh, with with the outside, and they have control over it. They can have control of what to share and what not to share. Yeah. But that will answer your question. Yeah, if your company or your institution like already defines this, but what if they don't? Yeah, then if they don't, there are some general repositories. So each of these repository will have its different use, like OSF, Open Science Framework. This is more like a Wikipedia style of things where people use it, for example, to share like research, like lab protocols and lab methods and lab, including data and lab data. Yeah, for example, Harvard data server, Figshare, Zenodo. Zenodo will not only share your repository, but you can share your repository and give it like a DOI from there, and you can connect it with GitHub, yeah, and Dry8. So each of these repository, you can like here I provide this link. This would be like a comparison chart. So like if you go to this link, that would be like a comparison chart, like telling you like different repository and which one to use it for which purpose. So like if you go here, for example, like uh, so that would be like OSF, for example, versus Dry8 versus Harvard dataset, and it will Zenodo, it will tell you like which one to use for which. Yeah. So there's this link here. But sometimes there is discipline-specific repository. So in hydrology, for example, you have HydroShare. That's a very cool repository. You'll go there, find a lot of very interesting hydrology data and hydrologic models that you can use. Yeah. Uh, but you could also have like national or regional repository. So here, if you are doing any research related to the Gulf of, now it's called the Gulf of America, but it used to be called like the Gulf of Mexico Research Initiative, then you share your data there. That would be like called the grid. So, and you go there, you find like all other researchers who are doing like research in the Gulf water, and then their data will be there, and then you can use this data. Now if you want to find like more about this national and regional repository, you can go there and you will find like a kind of a database of this like national and regional repository. Yeah? But now there is also not just like a repository where you share your data. Some repository will allow you to interact with your data. So here, for example, like here I shared my data on GitHub and Google Drive, where because GitHub, the free version of it, like it has like a certain limit on the file size. So if I have a big file, I put them on GitHub, and then Colab that will allow me to open my notebook and interact with them, and then I share this on GitHub. And if you want to play with this, I put you an example here. This is uh, an example, another example of instead of using Colab, I just use Binder. So again, these details are not important. Like I cover these details more in another course, like environmental data science. But for you, I just want you to be familiar with like that these tool, like this infrastructure is available for you to use. Yeah. So let me show you this example. Yeah. So that's something, for example, that I did before. So like this is a GitHub repository. See here, this is my license. So you can go like learn about my license. So here I have an MIT license. And then uh, if you go here, uh, if you go here, if you go here, uh, you just click, this is a binder, and then you open like, let me show you first this. Like before I show you in an interactive mode, let me just show you in like a, not in an interactive mode. Let me close all this. So not in like this is my notebook. See, so it is accessible, and you can also not just access it, but you can also uh, like you can view it also. So you can view this file with all like the details. I can open it in Colab. So like so that's like in Colab. So Colab now it will allow me to also run it. So like if I run it here, like I will run on Colab. So if I run this code, that will run on Google server. Yeah, that will not run on my machine. That will run on Google server. But see, it has like I think some access issue. But that's yeah, that's like if I but that's a code. Like if I want to run a code here, like a like that's a Python code. A is equal to 1, B is equal to 2, C is equal to A plus B, for example. If I run enter, then the code is running, let's say like print C, then you can guess the answer. The answer is 3. Yeah. So that's an interactive code. Yeah. So I can basically like if I want to run this, like let's say I'm having a research meeting with my colleagues or my student and we want to play with this code and see how we'll get different results, we can play with it. So you can do this in Colab. That's like called like Colab, or you can do this with Binder. So like with Binder, I just put like a Binder link here. Like if you go here, uh, leave, I put like, oops, like let's go to my repository. See, I put a Binder link here. I open my Binder link, and now you see here's my code, and here is my data and everything. So now I can run this, yeah, or uh, no modules named Panda. Yeah, so because I'm running this on the cloud, so you need to like install Panda first. So like pip install pandas. Yeah, so if you did like pip install Panda, then I should be able to run it. Yeah, but anyway, this is not important. Like you can pip install like these things, and then but the idea is that now I have a Python code here which I can run and interact with. So I'm making my data like easily accessible, yeah, by using like GitHub and Colab or Binder. Yeah. Now, how to make your data interoperable? Okay, I hope this video is not getting long, but I think it's useful. Yeah. To make your data interoperable, you need to use like common formats and vocabulary of your discipline. So, and each discipline, they will have their common vocab and vocabulary. So, for example, like in climate, like if you are working in climate science, you have like each country has its climate model or more than one climate model. Yeah. And how could you make the output of all this climate model consistent so you can analyze them? You need to have a common vocabulary. And see, this is, for example, so if you are doing an Earth system model, you need to, like, for example, like, and so this is, I mean, I haven't, so you can see this common vocabulary here. I don't know if we can standardize region, a standard name, for example, like you see, these are the standard name. Yeah. Let's say, like, for example, ZOS. Yeah. See, like surface height, like sea surface height above, yeah, sea surface height above JUID. So see, that would be like if you clicked here, it will like explain to you like what is this one and like what unit you need to measure this one with, and it will also give you like not in this document, but like if you go to another document, it will give you like the short, long name and short names that you use for your model for this one, like which is called like ZOS, for example. Yeah. So that would be an example of a standard name and vocabulary for your discipline. But again, this is beyond the scope of this of like uh, of 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 of, of this course. And for example, if you, this is groundwater mark up language, and if you want to learn about metadata standards, like disciplinary specific metadata standards, you can check this link. Yeah. But I just want you to make sure that like if you are developing like your own model or something like this, make sure that you use a common name so that your data would be interoperable not only by human but also by machine. So for example, like sea surface height, if all model are using this one, then I could go to all these climate model and tell them extract the ZOS data. Yeah, or whatever. And all this data would be in meter, not one would be in feet and one in meter and one in centimeter and blah, blah, blah. Everything would be in meter. Yeah. So it will make your data interoperable across like different platforms and different machines. Yeah. Now let's get, I think we are, this like the last part of this lesson is make like your data like reusable, and to make your data reusable, you need to provide license. So let me explain to, like, again, we are not lawyers here, but even though we are not lawyers and this is not our area, it's very easy to understand and it's very easy to know what type of license you need to provide for your work. So let's start by here, like public domain. Yeah. So that would be like, this is called like C Creative Commons, and that like Creative Commons, it makes this license process easy for us, like for non-lawyer to understand and use also, like make a product that's available for us to use, and we can select like any of these license to our data. So public domain means that you can copy and publish my data. You can commercially use my data. You can modify and adapt my data. You can change the license of my data even. Like if this was, like let's say you use my data in a commercial tool, and then you don't even need to make this data public. Like you can change the license and make it also commercial. Not, and you don't even need to attribute me. You don't even need to cite me and give me credit for this data. So that will be the most open. Yeah? If you want to restrict it a little bit more, it is, so this is CC BY. Yeah, so this public domain. CC BY means that if you want to use, you can do whatever you want to do with my data, but you need to say by one. You need to cite me. Yeah, you need to provide an attribution and say like provide credit for me. Yeah? Now here, see, this is CC BY and SA. So what is SA? So SA means share alike. Uh, so means that you cannot change the license. Like if this is whatever license I provide here, you need to share this data with the same license that I provided here. But you can still use it for a commercial purpose. Yeah, but you need to share it alike. Yeah. Now, this is like CC by ND. What does ND mean? ND derivative work. Like you can like you can copy, distribute, and display my data, but you have to use verbatim as is. You cannot change it. Yeah. So that would be like, so that would be more restrictive. Yeah. So here you cannot modify my data. You cannot change my license also. And NC means that like you can use my data. You need to attribute, like give credit to me, but you cannot use it for a commercial purpose. So that's NC here. So NC here, non-commercial. You cannot use it for a commercial purpose, and you can do any combination of these. Yeah, and that would be the most close. Like, so the most close is that you can copy and publish my data. You need to attribute me, but you cannot use it for commercial use. You cannot modify the license, and you cannot modify the data. So you need, again, which license should I provide for my data? Uh, that go back, make your data as open as necessarily, but as close as possible, but also consult with your supervisor, consult with your company, consult with, use your best judgment. So that's basically what license to use. You need to consult, like you need to discuss this with your company and with your supervisor. So before sharing the data, even for this course or your thesis, or you need to consult with your supervisor. Yeah. And and I had this before, like one student, for example, not in this class but on my other class, environmental data science, because the student need to share their code and using the best practice. And one student, she came, told me, I mean, I can share my code, but I don't want to share my data because this is my thesis data. I told her, of course you shouldn't. And I told her, what you do, just go online, put this, whatever you feel like comfortable sharing with that, like if you feel comfortable sharing the code, fine, like share the code. If you don't even feel comfortable, I told her, don't share the data, but if you feel comfortable sharing the code, fine. If you don't even feel comfortable even sharing the code, that's fine. All I want to see is that in that project, not in that course. So I told her, all I want to see in that course is that you are able to do this. So just get any code you did in this course, put it in that repository so that you can show me that you can share, like make your data accessible on GitHub or whatever, and then you will get credit. Yeah. So so use your best judgment. Yeah. Don't just like. So I think like, okay, so that will be our next video, is like how to be fair. Yeah. So now we learned about like this is concludes the why. So we learned why to be fair. Yeah. We learned what to be fair. Like, so this is the what part, like to make your data usable, you need to give it license. But like the next question is like how to be fair. And to be fair, to manage, you need to manage your data. Like you need to develop and implement a research uh, data management plan, not necessarily research data. Like in our case, in this course, it's research data, but for anything you're doing, you need to have a data management plan. And then you need to share your data following this principle, like make it findable by DOI, accessible by putting it in a repository, interoperable by using common formats, and reusable by providing a license. And next video, I will show you this. The video after, I will show you this. Yeah. So these are some additional slides just for the nerds. If you are a nerd student, and I'm not gonna go through them, but I will just display them here in this video in case you are interested. So this is fair data in a nutshell. So you can see what's the digital object, what's the persistent identifier, what are the codes and the standard, and what are the metadata. So you can read about this. Here are the fair guiding principle from this paper, which was publishing in Scientific Data. So you can pause this slide and read it. I'm not going to read it. Here is how to make like your data reusable. So you see this like terms like free software or open source software or a freeware or public domain software. Now here will provide you information. What does this mean? Like what does each of these terms mean? So you can learn about this. Now here is about the license. So what does copyright mean? What does copyleft mean? What does permissive mean? What does Creative Commons mean? And what are the difference between this like license or these legal attributes. So you can also pause this slide and learn about it. Finally, these are like the different licenses and what each license. So these are the kind of like a pre-packaged license for you. Like you are not a lawyer and you just want to use something. So for example, for your assignment, like which you will do, I want you to use this MIT license. So, and now you can see here, like when you select this MIT license, what access you are providing and what access you are not providing with this data. So it's not there's no patent, and you can be used in uh, closed resources. Like you cannot use it in closed resources. I think you can need to provide like a same license. Yeah. So I think, and here this is the last slides that I have here, which is it's the steps like how to like to share your data. You need to go through all these steps. Like you need to data profiling, you data so to in order to collect the data, you do like cleansing, data reduction, data transformation, data enrichment, data validation, and then your data is ready to be shared. I don't teach this in this class, but there is another class which called like environmental data science, where I teach a student how to do this with Python, like this all this process like of data sharing, like big data. Like let's say you have like a data that's like spreadsheet that is 10 million rows, and I'm not exaggerating, like 10 million rows, like how you can use Python to do this very easily. Okay, so I think that's all for this, and I will like see you in